This video will discuss the solution to question 30. What is a good approximation of the dominant pole frequency of the amplifier in figure 2? Firstly, we have to take a look which node is most likely to be responsible for the dominant pole of this amplifier. The node in the middle is connected directly to a common drain configuration. A common drain configuration gives us a gain of approximately 1, which isn't that large. The node here is connected to a common source configuration. It has been computed in question 29 that the common source configuration has an inverting gain of 100, so the effective gain is minus 100. And due to this large inverting gain, the Miller effect will have a very significant effect on the equivalent capacitance in this node. So therefore, it's most likely that this node is going to be the one that's responsible for the dominant pole. So let's make a small drawing of all the capacitances that are seen from that node. The capacitance between the gate and the source is connected on the other end to a constant voltage, namely VDD, and therefore from a small signal perspective is equivalent to a grounded capacitance when it comes to the time constant in this node. CGD, however, is connected between this node and the node where we will see the amplification of stage 1. From the Miller effect, we know that the equivalent capacitance that we will see as an effect of this amplification is equal to 1 plus the absolute gain of our stage times the original capacitance. So that is 101 times CGD. If we now want to find the full capacitance in this node, that will be equal to C equivalent plus CGS, which is 101 times CGD plus CGS. That is equal to 525 femtofarads. The time constant in the node is now equal to the total capacitance in the node times the total resistance in the node, which, since there is only one resistor, R sig, is just R sig. So the time constant is 525 femtofarads times 10 kiloohms. And that is equal to 5,250 picoseconds. Now we have the time constant, we can just compute the bandwidth or the negative 3 dB frequency of this pole by taking 1 over 2 pi tau. And that is equal to 30.3 megahertz. So we can approximate this by 30 megahertz.